The ancient Greeks thought that thunderbolts were hurled down by the god Zeus. Now, 3,000 years later, mere mortals can induce lightning to strike. What Ben Franklin tried to do with a kite, scientists are now doing with a rocket with a little wire attached.
Yes, it's actually really interesting that a little wire only going up a few hundred meters can bring down lightning from, say 5 miles up in the sky. So it's real lightning. You're just giving it a place to strike. That was a problem for a long time with lightning research. You never know where to point your camera, so we're telling it where and when to strike, so we know where to point our instruments.
Joseph Dwyer, a physicist at Florida Institute of Technology, can bring down the bolts, but he says how lightning starts is still unclear.
It's a huge mystery. It's one of the biggest mysteries in the atmospheric sciences.
Here's what we know.
Okay, lightning in many ways is a big spark.
To get a spark, you need a high voltage over a short distance. Voltage can be created by rubbing off electrons, like onto your socks, to create a difference in charge. You get a spark when those electrons jump from your finger to the knob, but
suppose that instead you start walking across the carpet, and suddenly when you were 10 feet from the doorknob, a spark suddenly flew out of your finger, and you'd think that something very unusual was happening there.
It's weird because the electric field created by a carpet walk would be too small to make a current travel that far.
And it's sort of a similar puzzle. When you measure the electric fields inside thunderstorms, they just don't seem to be big enough to make a spark.
And yet they do. So one hypothesis is that big electric fields actually do exist inside clouds. We just haven't found them yet. Another is that water in clouds helps facilitate the spark. But new research suggests there may be another possibility. Dwyer and his colleagues recently discovered that thunderstorm clouds and lightning produce X-rays, high-energy light particles. He says this may have something to do with getting the spark going.
Maybe there's this sort of strange, unusual thing going on where we have a lot of X-rays flying around, and that's what's making lightning go.
Once lightning begins, it doesn't come down from the cloud at a constant rate. It'll go about 50 meters.
And then it'll pause. It's like it runs out of steam or something, and then it will leap forward again. And then it'll pause, and then it'll leap forward in different directions. That's why lightning has this zigzaggy, branched appearance.
But how exactly the propagating works is fuzzy, too.
Nobody understands how lightning steps or even why it steps. And so, a lot of people get hurt by lightning, a lot of properties damaged by lightning, and yet we don't know at the basic level how it propagates.
And once lightning hits the ground, it shoots back up to the cloud in a return stroke, and that's actually the bright bolt that we see.
That's why lightning flickers. You're getting these separate strokes within a flash. In many ways, we know more about how the inside of a star works, halfway across the universe, than we do how lightning works 5 miles over our head. It's an area of science that I think a lot of people have overlooked. It's kind of like they're waiting for the clouds to go away so they can see the object way across the universe, where they're missing some of the most interesting science right above their heads.
3, 2, 1, fire.
I'm Flora Lichtman for Science Friday.